Good night everyone. In this section, we want to explaining about a secured web-based remote garage door system through the smartphone. First, before we begin this section, I want to introduce my team first. My team is consists of two people. There are Ricardo Agung Basana and Sadam Muhamad Hizbullah. And in this change, I will explaining first about what is garage system automation. Unlike the traditional garage door, we using Arduino for give the ability to open and close the door automatically just by pressing the button through their smartphone. Okay, after we know about what is the garage system automation, let's talk about the benefit of the garage system automation. Actually, there is a lot of benefit from this IoT, but I will just mention three of the major benefit from them. First is convenience, second is safety, third is technology. First, why this IoT is very convenient? Because it lets the user to open the door automatically. There are no need to get out from their car or maybe other vehicle. Just simple as they press the button and the door is opened automatically. Second is safety. When we talk about the safety, we all care about all the risks that can be happen with if we still using the manual garage door. Like our finger can be stuck with the door, or maybe for the older people, they can get cramp easily in their back spine. So just by pressing the button, we avoid that risk. So there is no more risk that can be happen with this IoT. Third is technology. Technology is there is a lot of advanced technology nowadays, and we can mixing them to this IoT, so we can freely adding the utility for us to feel more convenience or maybe more safety. There's about the benefit of the garage system automation. Okay, after we know about the fundamental about this IoT, let's talk about the requirement. This requirement section, I divided this section into two terms. There are about the software requirement. Second one is the hardware requirement. Okay, let's first talk about the software requirement first. There are four software that we need for this IoT. First is FreeZing, second Arduino IDE, third is PHP, and the last one is MySQL. Talk about the FreeZing. This application is let the user to make their prototype, so the user can make to draw the prototype of the electricity, so people can figuring about what they gonna make. Second is Arduino IDE. This one is the application that let the user to inject the program to the Arduino mainboard. The third is PHP. This one is the compiled language that we use in this project. And the last one is MySQL. This SQL is one of the is very famous among us. It just like the SQL language that let us to store the query to the cloud. Okay, after we know about the software requirement, let's talk about the hardware requirement. There are 6 hardware requirements for this IoT section. There are Arduino Uno for the mainboard. Second is the Ethernet shield. Third is the USB power cable. Fourth is the LED. Five is router, and the last one is buzzer. Okay, let's talk about the Arduino Uno first. Arduino Uno is the main board, or as we can say there, this one is the brain for the system. This I think help the program, help the logic, everything that we need about this garage door. Second one is Ethernet shield. This module let us to connect the Arduino Uno to the internet just by to connect the Arduino Uno to the router, so the Arduino can access the internet. The third is USB power cable. This is just a regular cable that let the Arduino to connect to the electricity, so the Arduino will gain access to the power source. Okay, the fourth is LED. LED just the indicator for the Arduino Uno. If when we open the door, the LED will lights up, and when we close the door, the LED will lights up too. So it's just the indicator for the user. Okay, the 5 is router. Why we need router to this garage door opener? Because we need to access this door through the internet. So this router will help us to connect to the internet from Arduino to the phone user. And the last one is buzzer. This thing have the same job decks like LED, just the indicator, but the difference with the LED, this buzzer one produce the sound. Unlike the LED, they produce the light. There's the difference just like that, but they have the same job decks as the indicator. Okay, after we finish the software and the hardware requirement, let's talk about the hardware assembly. Okay, first, there are just 4 steps to connect this thing to make it works. First, we just need to plug in the header pin from the Arduino to the Ethernet shield into the top of the Arduino Uno. Make sure the USB power cable is connected with monitor or laptop. Second, use the Ethernet cable to connect the Arduino Ethernet shield to the network via router. Third, note that the Ethernet shield is attached to the pin 10, 11, 12, and 13, so those cannot be used. Connect the positive end of the LED on the breadboard and in turn to the pin 8, and the negative end of the LED to the ground on the Ethernet shield. And the last one is connect to the positive end of the buzzer of the breadboard and in turn to pin 6 and the negative end of the buzzer to ground of the Ethernet shield. Okay, that's all from me. My friend Ricardo will explaining about the software assembly. Okay.
Hello everyone, my name is Ricardo Agung Basana, and now I'm gonna continue what my friend explained before. Continuing his chapter, now we are in software assembly. Once it's connected, the Arduino is programmed using Arduino IDE to interact with the device. Arduino programs are written based on this following pseudocode. Declaration, define MAC address and Arduino IP address. Define pin number Arduino. Define the period time of buzzer. Setup. Set the output of pin at Ethernet shield. Loop. Set the server to sense the data. Set the display to the system interface. If door open, LED is on. Else LED is off. It means if the door is not open, then the LED is off. If timer exit, buzzer on and then exit. It means if the door is open until several times that set in the system, the timer buzzer is turning on. And next, how does it work? In this chapter, we have 2 perspectives. First is user perspective, and the second is system perspective. Now I'm gonna explain about the user perspective first. In here, on the left side, we have login page. User must login into the system for using the system. If user want to open the garage, they must login as a normal user. If the user want to manage the user and the system, they must login as an admin or administrator. And on the right side, we have switching page. If login successful, the smartphone screen will display this interface. In this interface, if user want to open the garage door, they can click the open garage button, and if they want to close the door, they can click close garage button. Moving on, we have admin page. In admin page, user can manage all the user. Administrator can add, delete, or use a few buttons to see all the status of the user. and log out from the system. On the right side, we have register page. In this page, if user want to sign up, admin must insert the user ID, the name, the status, and the password for the user. Then click insert record. If the record successfully recorded, the page will display a view of user that recorded before. In this site, admin can delete the user by clicking the delete button. And then we have from system perspective. In here we have the diagram concept. The Arduino Uno is utilized as a microprocessor to enable the prototype remote garage door controller for sending the signal to the smartphone using device-to-device communication technology of I3E 802.3 standard. The command to open or close the door is sent from the phone to the garage door controller, whereby the controller will trigger the door sensor to move. And then we have the physical design. For this prototype, we replace the door arm into a LED to represent a state of the garage. If the LED is on, it means the garage door is open. But if the LED is off, it means the garage door is closed. A buzzer also will be triggered if the door is open within the time limit that's set in the system. The controller will send this alert to the smartphone to notify the user. The Ethernet shield is stacked into the Arduino Uno and connected to the breadboard. The buzzer and the LED also connected to the Arduino controller through the breadboard. Power supply for the Arduino also connected in the power port. And next is the conclusion. In this ISAS, we describe a prototype of a low-cost and energy-efficient smart garage remote door that's suitable for residential and office use. The prototype used a low-cost and efficient microprocessor called as Arduino Uno to realize a smart function such as sending instruction through smartphone for open the door and close the door if the user has been authorized. If the door is left open for too long, a buzzer will sound and notification to the smartphone will be triggered. This can help the consumer avoid the problem like key that left behind and missing. Also, a company that owns a small office also can use this system so they don't have to worry about forgetting to bring their keys. Okay, this is the end of our presentation. Thank you.